Good morning, students. So, in the last class, we discussed about the important reactions of that. What is that? Alcohols and phenols. Today, we are going to study with the important questions of aldehydes, ketones, and carboxylic acids. Okay. So, I'll write first the important questions in aldehydes, ketones, and carboxylic acids. Okay. So the first one, of course, nomenclature. Second, classification. Third, Nusseltman reduction. Fourth, Ithards reaction. Five, okay, Butterman-Koch reaction. Butterman-Koch reaction. Next, the next one is Stefan's reduction reaction. Seven, Redoxraft acylation. Redoxraft acylation. Next, Clemmensen reaction. Okay. So ninth one, Wolff-Kishner. In the place of Clemmensen reaction, you take Clemmensen reduction. And the 10th one is Clemens reagent. Reaction with Clemens reagent. Okay. 11th, Felix solution. Felix solution. 12th, allophone reaction. Okay. Aldol condensation. Crossed-Aldol reaction. Crossed-Aldol condensation. You will take. So 15th, Cannizzaro reaction. Cannizzaro reaction. Esterification. Okay. 17th, reaction with PCl5, PCl3, and SOCl2. Okay. So listen, students. From here, okay, this is carboxylic acid. Up to here, this is aldehyde and ketone. From 16 onwards, it is carboxylic acid reaction, preparations and the reactions, chemical properties. Okay. So the next one, 81 is bromination, nitration, 20th is the HV set. Health linking reaction. Okay, so this is all about very important reactions in the chapter aldehydes and ketones. And remember, this chapter carries 10 marks. 1 mark 1, 5 marks 2. Sorry, 1 mark 2, 5 marks 2. I can say. There is no 1 mark question means 2 marks 1, 5 marks 2. 5 marks 2 question is compulsory. So remember, in this chapter, so many named reactions are there. So all the named reactions are very important. Understood? So in that, the most happening is this Rosenberg, Richard, Wetterman, of course, everything. And these are the 3 marks. All done, crossed all done, are the 3 marks important questions. Okay, this one. And remaining are for 4 marks. Okay, then as 2 plus 2 plus 1. Or with example, if that's then as explain another reaction with an example R. So then give the reagent here. Okay, so which reagent? For example, an acyl chloride is there. That undergoes what happens when acyl chloride undergoes reduction? So in that you have to write the reaction and name the reaction there as that is Rosenberg reaction or Rosenberg reduction, like that. So the question will be like that. Means the reagents they will give, products they will give. So you need to identify the reactant or the name of the reaction. The name of the reaction carries as I told you 1 mark. So these reactions may be asked for 3 marks, like explain the reactions, do so and name the reaction. Okay, so we will discuss one by one. As I told you, I don't want to discuss this nomenclature and classification in this class because after completion of the amines, I will explain all the 4 classification and as well as nomenclature individually. So I will start with this Rosenberg reduction reaction. These are the very important reaction. If you read this much, that is enough for organic chemistry. Okay. Okay, so the next one is Rosenberg reduction reaction. Okay, here it is. Okay, so students, in this Rosenberg reduction reaction, so I'll write the reaction first. So what happens here? Acid chlorides undergoes reduction in presence of palladium as a catalyst. And BaSO4, especially sulfur, as a catalytic poison. So forms what we want? R C O H. That is in the right. RCHO here. RCHO plus HCl. So this is acid chloride. This one is aldehyde. Okay. So what is happening here? When acid chlorides are undergoing reduction reaction. Reduction means, as I told you, one is either addition of hydrogen or removal of oxygen. So here what is happening? Addition of hydrogen is happening. Where? To this group RCOCl. So here H is added. So addition of that hydrogen is called as what? Rosenman reduction reaction. Understand? So I'll explain the statement here. Then you will understand. Yes. Okay. Yes. When acid chloride undergoes reduction in presence of palladium as a catalyst, palladium as a catalyst, I will take here reduction in presence of palladium as a catalyst and BaSO4 as catalytic poison gives aldehyde. Understand? So this is the reaction going to occur. Why we need to use this BaSO4 as a catalytic poison means if we alone use this RCOCl is there in presence of H2 and only palladium is used, then here as I told you, the addition of this hydrogen takes place as well as removal of this oxygen takes place. Here 2 moles of H2 we need to take, they form RCH3 plus HCl plus H2O. Understood? So here 3 moles. Means instead of getting this aldehyde, we are going to get this alkane. So to reduce this product to what? This aldehyde, we require BaSO4. This BaSO4 controls the reaction. Understood? When it controls the reaction, what is catalytic poison? You know, one which decreases efficiency of the catalyst. If the efficiency of the catalyst decreases, the reaction rate also decreases. That means they form aldehydes instead of alkanes. Understood? So this is the reaction. So if we take the example here, so I'll take acyl chloride. In the place of acyl chloride, hydrogen is there. Say palladium, BaSO4, sulfur. Then the product formula is CH3CHO plus HCl. Okay, so here you need to write this one is what? Acyl chloride. Okay, acyl chloride. Or you may write acetyl chloride. Acid chloride, acetyl, acetic acid. Okay, next. This one is ethanol. AL I am writing. AL represents what? Aldehyde. So this acyl chloride, when it undergoes reduction in presence of these two, they form ethanol. Then you write this. So acyl chloride upon reduction with palladium as a catalyst and BaSO4 as catalytic poisoner gives ethanol. Of course, this is also the statement. Acid chloride upon reduction with palladium as a catalyst and BaSO4 as a catalytic poisoner gives ethanol. Compared to this, this is the easy statement. Okay, next. So here I am taking example 1 with what? Aliphatic compound. So here I will take example of aromatic, means this benzoyl chloride upon gives what? Without there will be CHO plus HCl. This one is benzoyl chloride. This one is benzenol, or in the right, benzaldehyde or benzenol. Okay, so here write the statement according to this. Acyl chloride in the place of acyl chloride, take benzoyl chloride. So what is happening here? This benzoyl chloride upon reduction, means reduction is happening here. Upon reduction with palladium as a catalyst and this BaSO4 as catalytic poisoner. As this catalytic poisoner gives benzenol. Remember, in all the three cases, what is same? The reaction process is same. Means both are undergoing reduction only in presence of this platinum and BaSO4 only. Here platinum is a catalyst, it gives the surface area for the reaction, and BaSO4 is the catalytic poison which decreases the efficiency of the catalyst. Why we need this catalytic poison means because the following reaction is very fast alone in the palladium. So instead of forming ethanol, they form alkanes. Means instead of forming this, they form ethane. So we need the product, what? Aldehyde. To what is that? To control the reaction from the formation of the ethane. To control the reaction from the formation of the higher alkanes, we require this BaSO4 as a catalytic poisoner. So both the reaction follows the same thing, nothing is changes, only the difference is for reactant and the product. If the reactant is acyl chloride, ethanol is the product. If it is benzoyl chloride, benzenol is the product. If it is any acid chloride other than these two, then aldehyde is the product. So this reaction is called as Rosenman reduction reaction. So remember, reduction means always. Don't think on the reaction. Why it is called reduction reaction? Why it is named also like Rosenman? Because he used these reagents. If these reagents are present, then it is said to be a Rosenman reduction reaction. Otherwise, I told you in the reduction reaction alone, palladium, platinum, or lithium aluminum hydride or sodium borohydride are going to be used. Here, so if they are used alone, that is the reaction rate is different. They form some other products. So this Rosenman scientist specifically by using these reagents, he explained the preparation of aldehyde. That's why this reaction is called as Rosenman reduction reaction. Understood? So this is one reaction. Next one is fourth one. Okay, so that is Ethard's reaction. Understand? Ethard's reaction. So what is this Ethard's reaction? So listen here. This Ethard reaction specifically for alkyl substituted benzenes. This is specifically for alkyl substituted benzene. So listen, here we need to form so what is going to happen here? Here CH3 is there, here CHO is there. Means oxygen is added. So addition of oxygen is called as oxidation reaction. Addition of oxygen. And at the same time here CH3 is there, here CH is there. Means 2 hydrogen is removed. 2 hydrogen is less in the product compared to the reactants. So simultaneously, if we compare hydrogen and oxygen, here there is no oxygen, here oxygen is there. Here 3 hydrogens are there, here only 1. So simultaneously reduction of hydrogen as well as addition of oxygen takes place. That is called as oxidation reaction. Okay, so this Ethard reaction is the oxidation reaction taking place by the addition of this oxygen. So here the reagents used is chromium or chromyl chloride CrO2 Cl2. Chromyl chloride vapors. Okay. So in presence of carbon tetrachloride as a solvent. This is the reaction. So students here, this Ethard reactions, why it is said so? Because this Ethard reaction, why it is said like that? This is for the preparation of benzene by using only alkyl substituted benzene, none other than alkyl substituteds. Understand? So this benzene ring should be said, what is that? Substituted by any alkyl group. I am not telling it is only CH3. Maybe C2H5, something, etc. But must have should be alkyl substituted. So how do you write? When methyl benzene, this is benzenol. So explanation, methyl benzene, okay, upon oxidation with chromyl chloride in presence of carbon tetrachloride as a solvent gives benzenol. This is the explanation. Okay. So methyl benzene upon oxidation with chromyl chloride. This is chromyl chloride in presence of CCl4 as a solvent, carbon tetrachloride as a solvent gives benzenol. So as I told you, here the reagent is what? Alkyl substituted reagent. So here in the place of that, you may take any other. CH2, CH3, you can take. Okay, so students, if oxidation takes place here, okay, so what is the product formed? CH2, CH4. Understood? So the product form is this one. So this is our what? That Peters reaction. And so instead of taking this, why I am taking this one is as a particular example because by taking this methyl benzene only, this ethanol explains the formation of benzene. This is Ethanol's reaction important for 2 marks. Okay, so the next one is Butterman-Koch reaction. Butterman, KOCH. Butterman-Koch reaction. So here we are using benzene. So this benzene is treated with carbon monoxide in presence of concentrated HCl and anhydrous aluminium chloride. So students remember this hydrogen is here, not only here, in all the carbon atoms having hydrogen here, NCH, because C6H6 is the formula of benzene. So then the product form here is what? I consider this functional group here. So this CO is inserted here, that is CH4. So this one is what? Benzene. This one is benzene. How can you say? So this benzene is subjected to carbon monoxide, or you may say it is treated with carbon monoxide. Okay, reaction with carbon monoxide in presence of concentrated HCl and anhydrous aluminium chloride gives benzene. Okay, so we write here benzene reacts with carbon monoxide in presence of concentrated HCl and anhydrous aluminium chloride gives benzene. So this reaction is called as what? Butterman-Koch reaction. So of course, as I told you, this particular chapter consists of so many named reactions. But here in the same chapter, if we once we know the reactions, that is final. There is no any other substitutes. So this is the reagent, this is the product. That is the reagent, that is the product. We cannot substitute any R groups. Like R is maybe CH3, CH2, like that. They won't ask. They directly ask Ketone-Koch reaction or formation of benzene from benzene, or formation of benzene from alkyl benzene, or toluene. So this methyl benzene is called as what? Toluene also, remember. In the place of methyl benzene, you may substitute this because benzene ring with CH3 is called as toluene. When toluene upon oxidation with this chloride in presence of CCl4 as a solid gives benzene. They may ask like this and name the reaction. Or write the reaction for the preparation of benzene by using toluene as a reagent and name the reaction like that. Okay? So they are very important. That is compulsory also. Okay? They should ask. Next. The next one is Stephen's reduction reaction. So it is sixth one. Stephen's reduction reaction. Okay, so what is this Stephen's reduction reaction? Here students, we are using stannous chloride SnCl2 in presence of HCl acid reagent. SnCl2 stannous chloride in presence of HCl. Which type of HCl it is? Concentrated HCl. Understand? So here the reagents used are alkyl nitriles. Nitriles means Cl type compounds. Listen. R, C, triple bond, N compounds. Which reaction it is? Reduction reaction it is. Okay? So in the reduction reactions, when hydrogen is added, as I told you here, it is standard chloride in presence of concentrated HCl. So students here they form R, CH, double bond, NH. Then further hydrolysis takes place. Means water molecule is added here. Okay, so here listen, H2 is there, O2 minus is there. So here what happens? R CH4 plus NH3. How the bond breakage will take place? Listen, R CH double bond NH. This H2 how it is dissociated? 2H plus O2 minus. Remember. So listen here, among carbon and nitrogen, this one is highly electronegative. This one is highly electropositive. Carbon and nitrogen, highly electronegative. So electron is towards nitrogen. If one bond break, this is one plus charge, this is another minus charge. If another bond break, so another charge, another charge. So this will get the minus plus 2 charge, this will get the minus 2 charge. Correct? So to balance minus 2, plus 2 is attached here. To balance plus 2, minus 2 is attached here. So there is RCH4 plus NH2. Understood? So this is the reaction taking place. Of course the mechanism is in a different manner. But I am telling you what is the key concept in this. Why it is like this. Why hydrogen is attached here, why oxygen is attached here. Understood? So to balance that. Now, how do you write? Of course, this is the general reaction. Alkyl nitriles. Okay? Under this reduction in presence of stannous chloride gives imides. Of course, these are called as imides. CH double bond NH groups are called as imides. Means when alkyl nitriles undergoes reduction in presence of stannous chloride and also concentrated HCl form imide. So followed by hydrolysis gives aldehyde along with ammonia. So if I write the explanation, alkyl nitriles, okay, upon reduction in presence of, in the place of upon you take undergoes reduction in presence of stannous chloride in concentrated HCl forms imide followed by hydrolysis followed by hydrolysis gives aldehyde. Aldehyde along with ammonia. Okay, so this is the explanation. Means alkyl nitrites undergoes reduction in presence of stannous chloride in concentrated HCl forms imine, followed by hydrolysis gives aldehyde along with ammonia. So I'll just replace this R group as it is a general reaction. So this is the example. One I'll take CH3 C triple bond N. Okay, so alkyl nitride, methyl nitride. Okay, plus 2H. So in the place of essential and concentrated HCl, they form imine. So in the place of R, we substituted CH3. CH3 CH double bond NH. Of course, it is also imine. Okay, so followed by hydrolysis gives CH3 CH4 plus NH3. So if we write the name, so this is methyl nitride. So this one is imine. This one is ethanol. So if we just replace this statement, so in the place of alkyl nitride, it is methyl nitride. So undergoes what? Reduction. In presence of the reagents used here is what? Stannous chloride in concentrated HCl forms what? Imine. After this, followed by hydrolysis. Followed by hydrolysis gives ethanol along with ammonia. This is the statement. Means methyl nitride undergoes reduction in presence of stannous chloride in concentrated HCl once imine. So followed by hydrolysis gives ethanol along with ammonia. This is one example. So if you take another one like benzene example. Example 2 it is whenever high load and then replace this by any of the output, if you take benzene, that is phenyl nitride. We are to take cyanobenzene, that is, okay, we write it as cyanobenzene also. And instead of that, you may write result. Initially, what I wrote, you may take instead of alkyl nitride, you may take cyanoethane. This is cyanobenzene. R, because this is the most clear group we have to give. Are you correct? Phenyl or benzyl nitride. So I take cyanobenzene. Quite easy to say. Essential to concentrated HCl. So give this benzene with the imine group. Okay. So upon hydrolysis gives benzene. So how do you write? Listen here. This is imine. This is benzenol. So I just replace the sentence here. Alkyl nitride. Cyanobenzene. Same follows. Undergoes reduction in presence of SnCl2 in concentrated HCl forms imine, followed by hydrolysis, gives benzenol along with. So this is all about what? Stefan's reduction reaction. Think in the Stefan's reduction reaction, alkyl nitriles are the reagent. So I just replace what are the reagents here. Of course, R here is what? Either oxidation or reduction reaction. I'll simply write one key concept for you. Today I did 4 reactions. So here, name of the reaction, here the process, reagent, product. Reactant, reagent, then product. Listen, name of the reaction, Rosen 1. The process is reduction. Reagent required is acid chlorides. Reagent is palladium in presence of PaSO4. Product is aldehyde. 1. Next second one is ethyl. Process is oxidation. Reagent bromine chloride in CCl4. Sorry. Reagent here is alkyl benzene. Okay, here it is bromine chloride in CCl4. Product is aldehyde. Next, after that, Fetterman-Koch reaction. Here, reduction, okay, addition. So here, the reagent is what? Benzene. Reactant. Reagents are carbon monoxide, concentrated HCl, and anhydrous aluminium chloride. This is especially here and here, benzene. Here is also benzene, fixed. Okay, next, another one is Stephens. So in this Stephens, this is also a reduction and hydrolysis, both. Reagent here, so reactant here is what? Alkyl nitride. Okay, so here it is stannous chloride in presence of concentrated HCl followed by hydrolysis. Here the product form is aldehyde. This is how you need to remember the reactions. Understood? So this is all about the 4 reactions what I did today. So we will continue with the next reactions in the tomorrow's class. Thank you.